In this tutorial, we'll make a simple combat behavior using HTN planning. We'll begin by making a character find a target and shoot at it. We'll then expand the AI to let it gracefully handle cases where it doesn't have a gun or ammunition. I'm using the advanced locomotion system for character animation here. You can download it for free from the marketplace following a link in the description. I've already set up a basic character similarly to how it was done in the previous tutorial. There is an empty HTN that the character calls into at the beginning of play, and the Blackboard asset set up for it. There is also very basic functionality for managing an equipped gun. The call to spawn gun here makes sure that the character begins play with a gun already equipped. Here's how it looks in the editor. If we hit play, we'll see that the character already spawns holding a pistol. All we have to do now is get the character to find the target, aim at it, and shoot the gun. Let's make a Blackboard key to store the current target. Let's call it current enemy. Let's set the key type to actors, that you can only put actors into this key. Now let's make a task that will find the player character and assign it to this key during planning. Blueprint class, base class of HTN task blueprint base. Let's call it HTN task find enemy. In it, during planning, we create plan steps. Let's get the player controlled pawn. Of the first available player. Check if it's valid. And if it is, assign it to the world state with a specified key and submit a plan step. Let's make the key a variable that you can edit in the HTN graph. Even though we're just submitting a change to the world state during planning, this change is applied to the Blackboard when this plan step executes. Let's assign this node's name. Now let's make a task for shooting the gun. HTN task shoot gun. In it, let's override the execute function. It is called when the task begins executing. The task will continue executing until the finish execute function is called. Let's set up a short delay before shooting. When we need to shoot, let's get the gun from the control pawn. Cast it to BP test character. If that succeeds, get its gun using the held gun variable. Make it a validated get so we can check if it's really there. And if it is, fire one shot. Then do another short delay and successfully finish executing the task. If we didn't manage to get the gun, we call finish execute with success set to false. Now let's set up the character's HTN. Let's make the character shoot at current enemy if it's set and find current enemy otherwise. Let's add an if node. And assign a shoot gun task to the top branch and the find enemy task to the bottom branch. Let's make it output into the current enemy key. Let's add a Blackboard condition decorator to the if node. Let's make a check if the current enemy is set. And let's call it has enemy. While shooting the gun, the character has to aim at current enemy. We could implement that in the shooting task itself, but it's cleaner to put it in a custom decorator that will then put in the shooting task. Let's make it now. Blueprint class, subclass of HTN decorator blueprint base. Let's call it HTN decorator aim at. When the underlying task begins execution, we'll make the character aim at the current target and stop aiming when the task finishes. Let's override the execution start and execution finish functions. On execution start, let's set the focus of the AI controller to an actor from a world state. Let's specify the key to be configurable. Let's call this aiming target and make it visible. On execution finish, let's unset it. Let's also take the controlled pawn and call BPI set rotation mode. This is a function from the advanced locomotion system. Let's set it to aiming. On execution finish, let's set it back to the default, which is velocity direction. Let's set the name of the decorator in the class defaults and turn off condition checking because there's no condition to check. Now let's add it to the HTN. Shoot gun, add decorator, aim at. Let's set the aiming target to be current enemy. Let's also add a wait task after shooting the gun. This way the character will not be firing continuously. Let's set the wait time to 1 second. Now let's see it in action. Play. And we see that the other character successfully found the player and is shooting at them, while correctly aiming and having delays after shooting. This has been pretty simple so far, but what if the character spawns without a gun? The character would need to get a gun first from one of these boxes. To make it happen, we need a few things: a task for finding a gun box, a task for taking a gun from a box, and a way to check if the character has a gun during planning. Let's make a general purpose task for finding actors of a specific type. Let's call it HTN task find by class. During planning, it will find all actors of a specified class. Let's override the create plan steps function. Get all actors of class. Make the class a variable that can be specified in the HTN editor. For each of the found actors, assign them to a key in the world state. And submit an alternate plan step. Let's specify the Blackboard key to be configurable. We're calling submit plan step multiple times here, one for each gun box we found. Since there are 2 gun boxes in the level, the planner will consider both the plan where it takes the first box and the plan where it takes the second box. In the end, the planner will take the plan with the lowest cost. The cost is influenced by things like total walking distance, and is specified by tasks when submitting plan steps. Now let's set the name of the task. Let's also set the default class. Now let's add a Blackboard key to store the found box. Let's call it temp actor because it will only be used to pass objects between consecutive tasks. Let's set the base class to actor. Let's also add a Boolean Blackboard key called hasGun. We'll use it to check if we have a gun or not during planning. Now let's make a task for taking a gun from a box. Let's call it HTN task take gun from box. We should let the planner know during planning that the effect of this task is to grant the character a gun. So in the create plan steps function, we set the hasGun world state value to true by calling set world state value as bool to true, and let's specify the key. And then we submit the plan step with this effect. Now during execution, we need to spawn an actual gun for the character. Let's override the execute function. Cast the controlled pawn to BP test character. If that succeeds, just call spawn gun and finish successfully. Finish execute with success set to true. Otherwise, if we didn't get a BP test character, call it with success set to false. Let's change the character so that they no longer start with a gun. Now let's change the HTN. First, add a check for if we have a gun on the shooting task. Let's check if hasGun is set to true and set the name of this condition to hasGun. Let's reorder them so it's at the top. Let's add an alternative pass to the top branch of the if node. Let's add the find by class task. Set the result key to temp actor and set the class to BP gun box. Not cluttered up, let's turn off show property details. And let's name it find gun box. If we're in this pass, let's move to it. That is the box we found. Blackboard key we're moving to is temp actor. And once we're there, take a gun out of the box. After that, the plan will be to shoot the gun. Now let's see it in action. You can see the character go to that gun box, take a pistol, and start shooting. Note that there are two gun boxes, but the character always picks the closest one. If we instead move the character over here, you can see them now go to this gun box instead. At this point, we have a character that can get a gun if needed, but there's no ammo handling yet. Let's make the character use ammo when shooting and get more from an ammo box when needed. Let's add a Blackboard key to store the ammo count. We should only be able to shoot if this count is above 0. Shooting will decrease this count. In the shooting task, let's override the planning function. Let's get the ammo count from world state and check if it's above 0. Let's add a Blackboard key for it. If it is above 0, let's decrement it by 1 and submit a plan step. Now that we support ammo, let's make a task for taking ammo from an ammo box. Let's call it HTN task take ammo from box. In its planning function, take the ammo count, add something to it, and assign that to the world state. Let's make the amount of ammo to add configurable. Make a variable to get the ammo count key. And let's submit the plan step. Now let's set the name of this task. Now we have everything we need. Let's make a new HTN and call it HTN get gun and ammo. Let's assign the correct Blackboard asset. Let's move the part for taking the gun into it. In the main HTN, let's use a subnetwork task to include this new HTN. Let's set the ammo count key on the shoot gun task. Getting a gun first or ammo first might affect total plan cost. So let's use an any order node to let the planner figure out which order is better. We'll use the top branch to get a gun and the bottom branch to get ammo. Let's reuse the find by class and the move to tasks in order to find an ammo box and move to it. Let's change the class to be found to BP ammo box. Now let's use the take ammo from box task in order to get more ammo. Let's set the ammo count key and set the amount of ammo to add to 5. Let's add a condition check to make sure we only get a gun if we don't already have one. So if we already do have a gun, we do nothing. But if we don't, we go and get one. We only need this check during planning, so let's remove checking condition on tick. Let's rename the find by class task here to find ammo box. Let's add another condition check to make sure we only get more ammo if we don't have any. ammo count is greater than 0. Let's turn off condition checking and plan recheck. With it enabled, recheck would expect the conditions to be false during the entire branch. This would fail because by the end of this branch, we do have a gun, and by the end of this branch, we do have ammo, which contradicts the conditions. You can find out more about plan rechecking on the documentation website linked below. Now let's see it in action. See the character get to the ammo box here, then the gun box here, then begin shooting. After shooting 5 shots, the character goes back to the ammo box to get more ammo. Note how they didn't go to the closest gun box here, but that one. That's because the planner knew that the total cost for going to the ammo box and then this gun box is actually shorter than going to this gun box and then this ammo box in terms of distance. It is in fact shorter than any other possible plan. The HTN planner will always find the lowest cost plan no matter how complex your task networks are.